Hello everyone. So on this video I'm going to talk about 4 types of probability distribution, and basically I'm focusing on the most important one of them, which is the standard normal distribution. So in your readings of topic 1, you have basically 4 types of probability distribution. We have the standard normal distribution, we have the chi-square distribution, we have the student T distribution, and we have the F distribution. Okay, so I want you to read these 4 types. Of course, in statistics we have more than 4 types of distributions, but we are focusing in this course on basically these 4. Okay, so on this video I'm going to focus on this one, give you an example on this one, and I want you to read the rest. Okay, the rest you have them under chapter 2 of your textbook. So the standard normal distribution is used, like I would say 95% in this course. Okay, so when you say a standard normal distribution, I think you remember it from your statistics course or your foundation course as the bell-shaped distribution. Is this kind of a distribution that has like a symmetry, right? It's centered right in the middle, and whatever you have on the right side is just a copy of what you have on the left side, so it is symmetric. Okay, and the standard normal distribution has an average, which is the center of 0, so it has an average of 0. The variance, which is the variation of the dots under the line, the variance is 1 because it is standardized. So we usually write it in a way like a standard normal distribution has a mean of 0, variance of 1, and this is how we usually write it in statistics. Okay, so you can write it as the standard normal distribution has a mean. We call the mean in this course as mu, okay, equal 0, and it has a variance. We call the variance in this course as sigma square of 1, and it is denoted as normal 0, 1. So if I say, for example, that I have a variable z, okay, and z is distributed as normal, or it has a standard normal distribution, then we can say that the probability that this variable z is less or equal to a certain number c, okay, we can always make our life easy and write it in this notation, phi of c. So every time you see this notation, let me write it in a nicer way because it looks weird. So whenever you see this notation, I want you to think it about it in your mind as less than or equal. Okay, so it is basically the cumulative distribution of all the points that are less than point C. So when I think about it in terms of the graph, then let's say this is point C, which is a certain number. Then I'm asking you, what is the probability of all the points, which is the shaded region, under the graph, which is less or equal to point C, then I'm talking about this shaded region. So in order to use the standard normal table, we must standardize. Standard normal table, you have it as I think table 1 of your textbook. We must standardize the variable. We cannot just go ahead and use a table which is called a standard normal without standardizing the variable. So what do we mean by standardizing the variable? We need to standardize the variable to have a mean of 0 and a variance of 1. So let me give you this example. Suppose that y is distributed as normal but has a mean of 1, so the average is 1, has a variance of 4. So remember, this is the mu, this is the mean, and this is the variance. Okay, so I have a certain variable that has an average of 1 and variance of 4. I cannot use the standard normal table to answer questions about this variable. For example, what's the probability that y is less or equal to number 4? I cannot answer this question if this variable is not standardized. To be able to use this, the standard normal table, I have to change this distribution to have a mean of 0 and a variance of 1. So how can we do that? So in order to do that, it's kind of simple. Take the mean out. So I have to remove the mean out of this variable. Each and every observation, we have to subtract the mean out. So y minus 1 has a distribution of 0, 4. Okay, the next step, I have to divide by the variance or the standard deviation, right? So y minus 1 over the square root of 4 has a normal 0, 1. So what we did is we had to subtract the mean out, get the mean out, and we have to divide by the standard deviation. And once you do that, this is the standard deviation, which is the square root of the variance, right? So once you divide by the standard deviation, you basically standardized your estimator. And at this point, you can start answering any question. You can start using the standard normal table. For example, if I ask you this question, what's the probability that y is less than 2? What is y? Y is this one. I cannot answer this question because y is not standardized. But I can use a standardized version of y by saying, okay, the probability of y minus 1 over the square root of 4, which is the standardized version that we have done it here, is less or equal, I'll take this 2, so 2 minus 1 divided by the square root of 4. So whatever you do on the left side, you do it on the right side. So you standardize basically both sides. In other words, this whole variable, which is the standardized version of y, I can call it z. What is z? Z is the standardized version of y. So I can answer the question by saying, okay, this is PR probability. The probability of z is less or equal 2 minus 1 divided by the square root of 4, which is 1 over 2. Okay, then in other words, I'm trying to answer the question, what's the probability that z is less than 1 over 2? If you go back to our first slide, we said if I have a question about the probability less than or equal to a certain number c, then I can make a shortcut and write it as phi of c. So that means I can always say, okay, this is the probability like this, phi of half or phi of 0.5, whatever, okay, 0.5. And then I can start looking at the standard normal table. So the standard normal table has, which is on the back of your textbook, it has it's a table, right? So it has like this. Some textbooks, they call it the Z table, but I prefer to call it the standard normal table. So they have like a Z here, and this table starts from negative 2.9, right? And then all the way to 0, and then all the way to the positive 2.9. And they have here the second decimal. So the second decimal, they put like 0, 1, 2, all the way to 9. So if I want to find the answer for what's the probability of the shaded region less or equal to 0.5, I'm looking at something like this. Of course, my distribution looks too thick, but anyway, so it's like 0.5 here, and I'm looking about the probability under the graph less or equal to 0.5. Okay, and then if you check your textbook, then you will find that this area is 0.691. How you find this? So you go first to this part of your table, you find here 0.5, and then what is the second decimal? Second decimal here is actually 0, so you go to the 0 and you will find here this number 0.691. Okay, 691. You don't see it, I'm sure. Let me write it again. So you will find it as 0.691. All right. So, and then you would be able to answer the question that this distribution, which is Z, right? This is Z, is distributed as normal 0, 1. Remember, the other version of it was the Y, right? The unstandardized version. So the unstandardized version had a mean, which is the Y, right? Had a mean, it was centered on 1, right? And it had a normal distribution of, sorry, it had a normal distribution, not a standard normal. It has a normal distribution of 1, 4. So what we did is we standardized it. We created a standardized version of Y that has normal 0, 1, and we were able to use the table on the back of your textbook. Okay, so let me show you the table. So the table, as I told you, it starts with negative 2.9, right? And this is the first page, and you have it as table 1. So you have here it's table 1, okay, table 1. But as you can see here, the first page ends at negative 0.9. So let's see the second page. So the second page here, so let's see, you go to the second page, you will find it right here, 0.5, second decimal 0, then you will find it here, right? So the distribution under the graph is 69.15%. Okay, so okay, so the distribution that we had, wait, just okay, so let me write it here. So the distribution that we had under the graph of the standard normal, centered under the 0, right? And this is the, let's assume this is 0.5, and this shaded region is 69.15%. Okay, and this is your answer to the question. As you read in your textbook, you have a standard normal distribution has a skewness of 0, has a kurtosis of 3, so you will find these in chapter 2 of your textbook. What else? I suppose, like, let me give you an example. If I'm asking you what's the probability that Z is less or equal to, let me just, 1.33. This is equivalent of writing it standard normal. Suppose this Z, like we said already, Z is a standardized, okay? So phi of 1.33. How can I find this number? So I'm going to 1.3 here, right? And then the second decimal is 3, so I'm gonna go to 3. So 1.3, this is 0, 1, 2, 3, so it's gonna be here. So this one is telling me it's equal to 0.9082. In other words, the shaded region under the graph of less than 1.33 is equal to 90.82%. I want you to notice that everything inside this table is basically percentages, right? So the answer of anything inside this table, percentages. Anything on the edges, like the column here or this row, is about a certain number. It's not a percent. So the column here, this one, or this one, are actually about these numbers which are right here, okay? And then whatever inside this table is about the percentage under the graph. All right. Okay, so I'll end this video here. I want you to read the chi-square distribution, the student t distribution, and the f distribution. I just focused on the standard normal because we will use it a lot. Okay, we will use it a lot throughout this course. That doesn't mean that the other distributions are not important. They are very important, but I want you to read them on your own. If you have any question, please post on the discussion forum.